analysis using Power BI. This topic is of great interest, and it's an analysis that is being used across board. When I mean across board, there is no sector in the world that does not require the usage of linear regression analysis. And we'll be demonstrating this analysis by using this wonderful tool by Microsoft called Power BI. And that will be our main focus for today. But before we go on, I would like to inform us that at the end of this section, there's going to be a quiz, and the quiz will be attached with the feedback form, and a gift will be given to the winner of the day, and also a swag will be posted to you. So we will arrange on how your gift is going to get to you. So just stay put, listen to every word I say, and every word I say also matters, because that can determine your score in the quiz. So let us start the lecture for today. What regression analysis is a set of statistical methods used for the estimation of relationships between a dependent variable called y and one or more independent variables. It can be utilized to assess the strength of the relationship between variables and for modeling the future relationship. Regression analysis is the estimation of relationships between a dependent variable and one or more independent variables. So that is the short definition that we can give to it. So what are we trying to say here? That there are two variables in a data set, and out of those two variables, you want to quickly look at those two variables to know if one of them, as it is increasing, is having a significant effect, either positively or negatively, on the other variable. Let's take, for example, maybe your price as against your cost of sales as against your profit. You want to see that as your cost of profit, as it is increasing, which will stand as your cost of sales, which will stand as your independent variable, that as your cost of sales is increasing, is it affecting your profit? So these are some of the things that we will be considering in today's lesson. Now, the uses of regression analysis. Regression analysis serve three major purposes. The first is the description. You can use from your regression analysis to describe, in order to detect patterns in your data set, to see so that you'll be able to tell a better story of what is actually happening in your data set concerning or as per two or more of your variables. Also, when you have detected, when you are able to describe, it means that you'll be able to control, which is the second major purpose. You'll be able to control how that variable will affect your how your independent variable will be able to affect your dependent variable on the long run or in the nearest future. And also we have the prediction purpose. It means that you can also use regression analysis to predict the a possible outcome. Now, there are three types of regression analysis model. The first here is the linear regression model. The second is the multiple linear regression model. Then third is a um, non-linear regression model. Now, of all these three, the most commonly used is the linear regression, which we'll be considering as far as our meetup or our lecture is concerned today. And the one that is not majorly used or often used is the non-linear, because it is the data set is complicated in the sense that the dependent and independent variables are they show that they don't have any linear relationship even right from the beginning. So most times people don't like using the non-linear regression, but rather they will love to opt for the linear regression, which we are going to consider today. And another another interesting fact is that regression analysis offers numerous applications in various disciplines, including finance. So you can look at you can use any of this model in any field, just like as I have rightly said. Now let us now look at the simple linear regression model. This model actually assesses the relationship between a dependent variable and an independent variable. So it means that two variables are considered here, which is one dependent variable and one independent variable. Unlike the multiple linear regression model, which is used for which is which is you have one dependent variable, and you can have up to 2 to 3 independent variable. That is, as the 2 or 3 dependent variables are changing, what effect does it have on the dependent variable? So here is the model that is a model equation, which we have y equals a plus bx plus ellipson. Now, at times the plus ellipson may not be added to this model. That is why I color it red, so that in case you are searching through the net and you just meet y equals a plus bx, so it means that in that particular model they did not add the plus ellipsing aspect. Now these are the definition of what it means. Now the y there is a dependent, it's called the dependent variable, and that is a particular variable that we are trying to predict, which is the y variable, which is the y. It is called the independent variable. And then the reason is because the y is dependent on the x. So that is why the y is called the dependent variable. Why the x is the independent variable? It is also called the explanatory variable, because we assume it is not depending on the y. And it is called the explanatory variable because it is supposed to explain what causes change in y. And that is the essence of the y. That is the essence of the x of the independent. So anytime the independent variable changes, it means that there must be an effect on the y. Also, the b or the a here is the intercept. It is called the intercept, or the point at which the regression line. All this I will explain by the time we get to the model itself. That the a is the intercept, or the point at which the regression line will intersect with the y-axis, and while the b is the slope. is the slope of the regression line. The slope reflects how large or small the change in y will be for a unit change in what? In x. So we'll look at it. The ellipsing is called residual, or it is also considered as the error. Now, values that we are to determine that is values to determine relationships. Now we are going to look at two statistical values to determine if there is a relationship between the two variables and how closely related they are. Now the first one is the coefficient of correlation. Coefficient of correlation is a statistic we use to determine if there is a relationship between two variables. The output of these statistics equals somewhere between 1 and -0. So it means that the result you'll be getting when it comes to coefficient of correlation will be ranging between 1 and minus 1. So it means you can have a relationship of you can have result of 0.9, 0.97, 0.1. All these are figures that are ranging between 1 and -1. You can also have minus 0.9, minus 0.2, minus 0.1. All these are figures that we may be encountering when it comes to coefficient of relation. And the closer to 1 the number is, the more positively related the two variables are. That is, if the x increases, y also must increase. So it means that there is positive relationship. But if it is closer to -1, it means that the relationship between the two variables are negative. So I repeat, if your result you are getting is closer to 1, it means that that the two variables are positively related. But if the result is closer to -1, it means that the two variables are negatively related. It means that as x is increasing, y is decreasing. But if it is positive, it means that as x is increasing, y also is increasing. And this is denoted. We can denote the coefficient of correlation as r. So by the time we'll be practicalizing the demo, you will see how we are going to determine our R. Also, the second thing that we are going to, or the second value that will determine relationship, is the coefficient of determination. Don't confuse both of them. The first one is coefficient of correlation, while the second one is coefficient of determination. And coefficient of determination is denoted as the R square. So please don't mind my writing here. I didn't edit this correctly. So this is supposed to be coefficient of correlation. So, and the essence of this is that you will be getting figures between the value of 0 and 1. You can't get any negative value in this place. And what it means is that the closer the value is to 1, it means that our model of the it means that our model fits the data set. But if the value is closer to 0, it means that our model does not fit the data set, and it is denoted as R2. So these are scenarios where we can use simple linear regression. Number one, we can use it in manufacturing firm to determine production and sales. That is, what is the relationship between our production and our sales? And you know that anytime that if you produce an X number of product, it is expected that you should sell a Y number of product. So as you continue to increase the production, it means that sales is supposed to be increasing alongside. But if sales is not increasing alongside, it means that sales is having negative relationship with our production. But if the sales is increasing alongside with our production, it means that there is positive relationship between our production and our sales. So we can also use that to determine a relationship between cost of production and profit. Even in insurance firm, they heavily rely on regression analysis to estimate the credit standing of policyholders and a possible number of claims in a given time period. And marketing firm uses analysis to determine the effectiveness of their marketing. Like, for example, a company is running a promotion on a particular product, and then you now begin to look at, okay, what is the effect of that promotion on our prices? Is that promotion actually, or is the price actually affecting our promotion on sales of a particular product? So with this, you'll be able to determine some of all these things using regression analysis. So let us quickly look at a data set and see how we can model a data using, that is, how to come bring out an insight as far as our regression analysis is concerned. So let me quickly open up Power BI so that I will bring up a data set. We will now see how to use Power BI to determine some of these things that has been mentioned. So let me quickly share my screen. Okay, let me share my screen so that we can view that in Power BI. All right. Now, here is a sample data set that has to do with car price. We want to determine the effect of some of parameters. Let me open this up so that we'll see some of the parameters. On this data set, we have the aspiration, we have the ball ratio, we have the car ID, we have the car body, we have the car height and the length, we have the car name, we have the car width, we have the city MPG, we have the compression ratio, we have the curb weight, cylinder, and all that. And then we now have the price of each of the vehicles. Okay, let me open it up in the table format so that we'll quickly see what the data is all about. So these are some this is how the data set looks like. Now, at the end of this data set, we have what we call the price. Now, we want to now see if in the nearest future, anytime there is a that is, we want to see the stroke of the engine, if it has effect on the price, or we want to see the horsepower of the engine of the vehicle, maybe it has a positive or a negative effect when it comes to the pricing. We can also look at the compression ratio to see if it has a positive or a negative effect. Even the engine size, we can know if it has a positive effect on the price of the vehicle. So now it means that the engine size will become the independent variable, while the price, which is the one that changes, will now be the dependent variable. So let us quickly see how we can do that in Power BI. Now, one of the things that one of the visuals that is being used in order to determine this most times is the scatter chart. It is the scatter chart that we use in order to determine the relationship between two variables. So let me bring up the scatter chart. So here on the the panel that is on our canvas, we have the scatter chart. Now, on the scatter chart, now look at what we have here under the visualization details. Under the visualization pane, we have the details, we have the legend, we have the axis, that is the S axis, which will be the dependent, which will be the independent variable, and then we have the Y axis, which is the dependent variable. So we have size, we have the play axis, and all that. But the three that is most important to us is number one, the details. That is what we are going to take cognizance of. Number one, the details. Number two, the S axis, and then number three, the Y axis. Those are the three important values that we may need to supply here. Now, let me bring in the price. And the price is the dependent variable, so it will be in the Y axis. So I'm dropping it on the Y axis. Okay. Now that I've dropped the price on the Y axis, I will now bring in the engine size. Okay. So we want to determine if the size of the engine, as the size of the engine is increasing, does it have a positive or negative effect on the price of the price of the car or the vehicle? So let me now bring in the engine size to the S axis. Okay. Now that I've brought it to the S axis, you can see that on the chart it's not giving us anything. So you now bring up the engine size again on the details. Okay. But if you are having a data set, that has to do with time and date, I beg you, please, on the details, bring in the date, and you ensure that the date is not in hierarchy. Okay, the date you'll be bringing in is not in hierarchy. But in a situation whereby you don't have a date on your data set, please bring in on the details value, please bring in what you have supplied in your S axis. Okay, so we have brought in the engine size on the S axis, and then we also bring it in the details, and then we brought in the dependent variable, which is the price. We have placed it on the Y axis, and then we have this. Now there's another thing that we must bring in here in order to discover patterns in our data set, and that is what we call the trend line. Now, to insert the trend line, look at what we have here. We have the analytics button. Click on the analytics button, and then the first thing you see there is the trend line. So I want to bring in the trend line, and I will open up the trend line and then say add. So immediately I add it, you will see the trend line. Now, what is the essence of the trend line? Now, if you are having the trend line, if your scatter, or if your data points are closer to the trend line, it means that there is positive relationship between the price and the engine size. But if your data points are far away from the trend line, it means that there is that is the relationship between them is negative. It is either negative or it is neutral, or there is no relationship. No relationship means it is zero. But if it is tending to -1, it means that there's negative relationship. But if it is tending to 1, it means that there is positive relationship. So I can tell you from here that the price, that is the engine size, has a positive relationship between has a positive relationship with the price of the car. So it means that as the engine size of a car increases, it means that there is possibility that the price of that car will also increase. So if the engine size reduces, there will be a negative relationship, because the engine that is the price of that vehicle will also reduce. Now, in order to further confirm this, like I said in my presentation, that there are two values that we must determine. Number one, we want to determine the coefficient of correlation, which is denoted as our R. Now, in order to do that, in order to determine our coefficient of correlation, to determine that, we will have to bring in what we call a quick measure. Now, to bring in a quick measure, I will right click on my data set and say new quick measure. So I want to bring it in. So it will pop up a dialog box for us. Okay. So the dialog box is now up. Now look at where we have calculation. You drop it down. When you drop it down, you scroll down. Here we have mathematical operations. Under the mathematical operations, this is what we want: correlation coefficient. So I'm clicking on the correlation coefficient. Now, look at it. We have the category. Don't forget, I told you that the same way we apply it on our data set is the same way we apply it here. So for the category, I will have to bring in the size of the engine. Okay, so let me bring in the engine size and place it here. And then for the X measure, the measure of independent variable, which is also the engine size, and then the measure of Y is the independent variable, is the dependent variable, which is the price of the car. So I'm dropping the price here. So you can as well maybe change what you have here to average, whichever one you want, and that will also determine the effect here. So I'm okay with what I have here, and then I will click on OK. So actually, if we are to write the DAX of this particular, this is what we will be. This is what we would have written. So the DAX is going to pop up now. So it's working on it. So this is what we would have written as against what we just displayed by. So let us have that. Okay. So this is the correlation between engine size and the price. So this is what we would have written when it comes to the DAX. But the quick measure, I've quickly run through our data sets and then bring up this calculation to give us our correlation of our to give us the correlation between our engine size and the price. Okay, so let me drop this. So we have this is the measure that we have brought in, the engine size and price. Okay, so I can rename this or still leave it as this. Okay, so let me leave it at this. Then I will now bring in another visual called card, so that we can see if it is tending to positive or tending to negative. So it's going to bring out for us a figure. So let me bring up the card. So the card is up here. So on the card, let me reduce this. On the card, I will now bring up the engine side. That is the measure that we have created. So I'll click on that. Wow, you see that it is 0.91. So from here I can confidently tell you that there's positive relationship, because 0.1 is closer to 1 than -1. So meaning that there is strong or the relationship between the engine size and the price is highly positive. Okay, so how do we now determine the correlation of determine our second value? which is our R2. So this is our R, and then we are going to determine our R2, which is the coefficient of determination. So what we have determined here is the coefficient of correlation. So how do we determine the coefficient of determination? It is to all you just do, what we have gotten here in the measure, we just raise it to the power of 2, and then we get our coefficient of determination. So how do we do that? The same way, instead of bringing in a quick measure now, we are going to bring in a new measure. So when as we are bringing in a new measure, we are going to name that new measure. Okay, still working on it. So we are going to call that new measure, let us call it our R2. Our R2 for engine size and price. Okay, so this is the measure. So we'll now call up our calculation we add in our R. So how do we call it up with I'm calling, okay, this is it, engine size and price. So I'm choosing this. Then I will now use my raised to power. Raised to power is shift 6, that is carat. Okay, so shift 6, then we now put 2. So it means that our coefficient of correlation raised to the power of 2 is going to give us our correlation of determination. Sorry, our coefficient of determination. So after that, I press my enter. So it's going to bring up our R2. It's going to run our R2 calculation for us. Okay. So after the calculation, I will come down and then look for that calculation, which is R2. This is it here. So I will bring in another card to see the figure that I've gotten, if actually this this model fits our data set. Okay, so I'm bringing it up by clicking this. Okay, so I've added this. Wow, this is 0.883. So it means that the relationship between the engine size and the price of the car is 0.83, and the interpretation for this is that this our model fits this data set that we have analyzed. So that is what that is how we can determine a relationship between two variables. At this juncture, if there's any question, please feel free to ask. Any question? So this can be used for as many this can be used for as many things as possible. That is, you can use it for different organizations. So many sector needs the use of regression analysis to determine the relationship, whether the relationship between two variables are actually negative or positive. So any question so far from what has been said?
Hello, Shooks. There's a question for you. So the question says, thank you very much for the insight. A question, please. If we interchange the price for the engine size, i.e., place price on Y axis and the engine number on X axis, do we get the same correlation results?
Okay,
so let us. If you make the dependency independent and the independent dependent, what will happen to our results?
Okay, so let us see. Let us quickly practicalize that so that we will see what the result will be. So, and that is the essence of the class for today. So let me bring in the scatter plot. So the scatter diagram is coming up. Okay, so we have the scatter chart here. So I'm bringing up the engine size. Okay, where are you? Okay, this is the engine size. I'm placing the engine size on. Okay, so the engine size is on the y-axis. So I'm bringing up the price on the on the on the x-axis. So the price is on the x. Okay, so the trend line will tell us if the relationship is positive or not. Add the trend line, add this, and then we have the trend line. Okay, so there is a positive relationship, but the figure might not be the same with with what we have before. So in order to determine that, so I'm bringing up, let me quickly calculate, bringing in a new quick measure so that we can see the effect of this on our data set. All right, so I'm bringing in the correlation of coefficients. Okay, bring in the engine size and put it on the y-axis. Bring in the price, scroll down, bring in the price, add it on the category, bring in the price again, add it on the x-axis, and then say okay. All right, so we have that. Okay, so it's calculating. All right, so let me bring in the card visual so that we can use to determine the result. All right, so here is my calculation. All right, so we have it here. So I'm bringing in the figure here. So this is 0.82. So it means that the result is not the same. Okay, on for the other way around, it is 0.91, while this other way around is 0.82. However,
okay, so
we can still say that
thank you.
the relationship is positive.
Okay, thank you very much, Shooks. But the underlying factors still remain. What exactly is your base value? What are you
Yes,
going to
that is the main
vary?
thing.
We are working towards seeing the impact on price. So that should be your Y. While your S is any other variable that you want to measure against the price. So that is just the baseline. So thank you very much. Any other question? Okay, there's a question from Shioma Okafor. Okay, she said the question has been answered. Thank you. So another one from Emmanuel. So, but the other one, engine size, was used. Okay, I think Emmanuel is trying to address Shoma's question. But what you always put in your category is what you have in your S axis. While
X-axis,
your Y
yes.
axis is your primary, your base factor that you want to increase or decrease. That if I increase my price, what happened? Is there a relationship with the engine or with any other parameter you want to use to measure with? So thank you very much, Shooks. Please, is there any other question? Any other question? Okay, so please, if you are interested in playing around with what we have. So, okay, I can see a hand up. Samuel. Hello, Samuel. Over to you, please.
Yeah, good afternoon.
Yeah, good afternoon.
Yeah, thank you very much, Mr. Achuk, for that session. It was very insightful. So I just wanted to quickly ask if, based on the trend line, if we now want to do like a predictive analysis, say I want to say, if I have a new data for, if I have a new data value for engine size, can I determine the price? So can I forecast with with this trend line that we basically have on our scatter plot?
Okay. Okay, that's a good question. So if you have a new engine size, I want to have a very good price that can go with that engine size. It should determine, it should predict what price should I place on it. Okay, Shooks, over to you.
Okay, so yes, by the time you have a new data set, it means that that data will be added to what you have on ground. So most times in situation like this, if you in order to deal with such, there are other things that will be put into consideration before that forecast can actually happen. So for now, we only determine the relationship, and we say that definitely it means that the higher the price. Okay, so so maybe in another subsequent class, we will now see how we can now forecast using this particular model. Okay, so it will take us a little time in order to achieve that, but for the sake of time, we will place that as another class entirely that has to do with forecasting using this same model. But we are very certain that if you increase the size of your engine, and then you increase the price of your you increase the price of that same car, there's all possibility that people are going to there's all possibility that your customers are going to that um buy that uh, buy that particular car, because you have increased the size of the engine based on this model that we have here.
Okay, so thank you very much, Shooks. So what we have done today is to actually work on linear regression. So for the prediction, so we can actually fix another date, and I hope, Shooks, you are ready to come up again to give us detail around prediction. So all these parameters, they are under analytics, and we are going to explore most of the parameters we have there during part 2 of this session.
One of the
So
teams
that's a very good question.
they haven't had the support of the fans.
Hello,
People telling
is there any
you
other
that
question?
rivals that they will go to play Eibar at Eibar's ground, and
Hello? Okay, I thought somebody is trying to ask a question. So if there's no other question, so thank you very much, Shooks. And as he has rightly said, we'll have a part 2 to this section where we'll talk about predictive analysis and determining the best price. I love that question. If my engine the size has been increased, can you tell me the best price that will fly in the market? Wow. So please, Shooks, I will love you to agree on a date you would like to come up and give us the second part of this section. So thank you very much. So
One question, please.
Okay, question.
Yeah, okay, so I sent the question in the group chat, just that it wasn't attended to.
Oh, sorry.
Right. Okay, so I just want to know if you can have access to the data set that is being used to carry out this modeling.
Okay, good.
Yeah,
So
yeah.
thank you,
Thank you very
Harry, for
much.
that question. So the data sets will be uploaded alongside with the video. By tomorrow, latest Monday, the video will be on our channel. So we have our channel, that is, just type Naija Power BI Saturday on YouTube. You always get to our channel. So once you get there, the video will be available. So down the video, there will be a link where you can get the data set. So That is that. And Shooks, the data set and the PowerPoint slide, can you make the two of them available for us?
Yes, definitely it will be available in as much as soon as we upload the the video to our YouTube channel.
Okay. So thank you very much. So that will be made available for us. So once they upload the material, you gain access to it. So thank you. Please, on the meeting chat, the feedback link has been dropped. Shooks has dropped the link for the feedback and for the question as well. So please click and quickly attend to it. So as you attend to it, the results will be displayed and your material, your prize will be given to you with your electronic badge. So it will be given to you. So please, once you are announced as the winner, you can always discuss. Let's know how to get your gift across to you. I hope we've all started. Let's quickly lay our hands on that. So Shooks, can you confirm when are we closing the pool so that we can announce the
Okay,
winner?
so we have 354 here. So by 358, announcing the winner.
So by 3:58, we announce the winner. So quickly attend to it. Thank you, Onyinye. Well done, Shooks. You've done well. I love that. Thank you very much for that feedback. So let's quickly click and attend to the feedback form and the few questions that will be given tied to the feedback form. Quickly attend to it. Okay, I can see another question here. Is there a way to assess the factor responsible for change? Let's assume there's a change in price. We want to see all the factor responsible for change. Is there a way we can see that? Maybe one of our class, one of us will talk about key influencer. So
Exactly.
key influencer will tell you what are the things that influence change in anything. So any data you have, there is one BI tool. Shooks, you can show it to us. Under home or insert, go to insert on your screen. Go to insert.
I'm in the SAT now, so this is the key
Okay.
influencer.
Under insert, look at that tool. That is a wonderful visual. It's one of the 4 AI visual that Microsoft gave to us, and that is key influencer. So maybe one of one of us will talk about it, and we will learn how to use it inside out. So thank you very much for that question. So I hope I'm not missing out any question. Okay, Rashid, this is a great section and very insightful. Thank you very much, Rashid, for that feedback. So, okay, thank you all. So we're also waiting for some of you to come up with interesting topic. The community is to leverage and to learn from each other, and let's solve problems you meet in the office. If you are facing any challenge in the office, bring it to the community and let's see how we can solve that problem. So please, let's start to round up. Just less than a minute more. Let's round up so that Shooks can announce the winner section.
The striker.
Okay. So thank you very much. So we have gotten to the end. This is 3:58. So Shooks, can you publish the winner? How many people attempted and who is leading?
6 people attempted the question, while the winner for this edition is Emmanuel Awa with 40 over 50.
Okay.
40 over 50. So congratulations, Emmanuel Awa.
So Emmanuel Awa, congratulations. So you've done well. 40 over 50. That's a nice attempt, a great attempt. So Emmanuel, I hope you are based in Lagos.
Yeah. Did I win? Wow.
So
Nice.
congratulations, Emmanuel. So you've won for yourself a t-shirt from the community, a
Woo!
writing material, a jotter, and a biro from Microsoft.
Haha.
So let's know how you want to pick it up. Just contact us so that we know how to get it across to you. And you also won for yourself a badge that you can fly on your social media platform as somebody that have cleared all our questions on our weekly event. So thank you very much. So Shooks, over to you. Any other thing?
All right. So thank you everyone for your wonderful how you have been able to support this community by coming up to join us in today's edition. So we'll be expecting more of you, and also expect more of this quiz from us. And we will not relent in ensuring that we will distribute the prizes according to those that have won. So for the previous edition, which happened in April, we had the winner for the first edition, which is Victor Eze, and why the second person on the winning streak is Emmanuel Awa. So congratulations again, Emmanuel Awa. So we'll see all of you also next week as we have another powerful speaker on the platform. So thank you. Take care and have a lovely, nice day.
Thank you very much, Shooks. You've done very, very well. It's a wonderful presentation. So, and we hope you prepare for the second part of this section. So thank you once again, and thank you all. So do have a nice time. Bye.
Bye.
Thank you. Bye.
Thank you.
Bye.
Yeah.
Thanks.
Chioma
Thanks.
Okafor, thank you, Mr. Shoes. Thank you for that comment. Franca, great section. Thank you. Congratulations, Emmanuel. So thank you all.